Okay, guys, today we're going to go through lesson 4.2 dealing with the niche and community interaction. So, first thing that we need to do is define what a niche is. Now, every organism, every species, every individual of every species on Earth has what is called tolerance. Now, tolerance is defined as the ability to survive and reproduce under a range of environmental conditions. Now, every species on Earth has this optimum range. So this could be everything from temperature to the amount of water to the amount of a food source. Some animals require a lot more food than others. You look at the different types of soils that plants need. We have this optimum range of all that are present. Okay, so when an environmental condition like temperature extends beyond that optimal range in either direction, either the upper limit or the lower limit, we see that the organism or the species as a whole can experience stress. The organism must expend more energy to help keep everything going as it should be, that maintaining of homeostasis than it normally does, and therefore gives a lot less towards growth and reproduction. So organisms have an upper and lower limit for every environmental factor. So a species' tolerance for environmental conditions then helps determine its habitat, or the general place where an organism lives. Now, what we end up seeing, just to jump ahead a little bit for some of our next lessons, is that we have some characteristics that are common amongst the plants and animals that are found in different habitats. So, defining the niche, what it is, an organism's niche describes not only the environment where it lives, but how it interacts with biotic and abiotic factors in the environment. So both the living and non-living things. So it includes not only the physical and biological aspects, but also the way in which it uses them to importantly survive and reproduce. So within this niche, we have to look at our different resources, things like water, nutrients, light, food, space, or even the availability of a mate. Okay, we can consider that loosely as a resource as well. Now, plants resources include things like sunlight, water, soil, nutrients. They can include space. You think about some of our large trees. They need a lot of space to grow to their full adult size. For animals, though, resources include things like nesting space, so where they can call home, so to say, shelter, types of food, and places to feed. Now, the physical aspects of the niche, it involves the abiotic factors it requires for survival. So you look at amphibians. Most of them lose and absorb water through their skin, so they have to live around some type of body of water or a place where there's very, very wet or moist soil. If an area becomes too hot and dry or too cold for too long, most amphibians cannot survive. There are some exceptions to this, which we'll talk about later. Now, the biological aspects involve the biotic factors, things like when and how a species or organism reproduces, the food it eats, the amount of food that it eats, and the way of how it obtains that food. So birds we have this example of birds on Christmas Island in the Indian Ocean. They all live in the same habitat, but they prey on fish of different sizes and feed in different places. So because of that, they each have a different or distinct niche. If they did not, we would start seeing them compete for that food source. So that moves us to the next part of our lesson. So competition. How does competition shape a community as a whole? Well, how one organism interacts with other organisms is an important part of the niche, and competition will essentially attempt to use the same limited ecological resource, so whether it's space, a food source, nesting region, soil, whatever the case is, they're trying to compete for that same limited resource in the same place at the same time. So animals will compete for resources like food, mates, and places to live and raise their young. It can occur between members of the same species. This is known as intra-specific competition, and between members of different species known as inter-specific competition. So make sure you can distinguish between those two. Now, this leads us to the competitive exclusion principle. So when we have direct competition between different species, it always gives one winner and one loser, and ultimately the losing species will die out. Okay. Now we have this example of two different organisms here. We have Paramecia aurelia and caudatum. They were first grown in separate cultures. You can see what occurs there. And we see their population size increase to a point and then level off between around day 8. Okay, now the dotted lines represent when they are grown separately. However, when they grow them together, we see in this solid line, what happens is that Paramecium aurelia outcompetes Paradisium caudatum, causing caudatum to go extinct by day 14. So this leads us to the competitive exclusion principle. Now, what it states is that no two species can occupy exactly the same niche in exactly the same habitat at exactly the same time. If two were to try and occupy that same niche, one species will be better at competing, causing the other to die out. And as a result of competitive exclusion, natural communities rarely have niches that overlap significantly. There is some overlap, but it's not to a point where direct competition will lead to the extinction of one species. Now, this is done primarily by dividing resources. So we have this example of North American warblers. Now, what we see here is this. We have three distinct species of birds, the Cape May warbler, the bay-breasted warbler, and the yellow-rumped warbler, and they pretty much simply divide their nesting space. So the Cape May will nest in the upper parts of the tree, the bay-breasted will nest in the middle part, and the yellow-rumped will nest in the lower part. So because they feed on the high branches, nest on the high branches, they don't compete directly with these two. Now, does that mean that we have a clear, solid line like we see represented right here, where the Cape May and the bay-breasted suddenly don't compete? No, there is a little bit of overlap, but not significant enough to where we have competition directly affecting both of them. And the same can be said for the yellow-rumped and the bay-breasted right here. There is only a slight bit of overlap, but not enough to be considered competition. So the resources utilized by these are similar, yet different. Therefore, they each have their own niche, and competition is minimized. Now, let's talk about predation, herbivory, and keystone species real quick. So we should already have an idea of what predation is from our previous lessons. It's an interaction in which one animal, the predator, will capture and feed on another animal. This is called predation. It can affect the size of prey populations in a community and determine the places where prey can live and feed. So that's what's being eaten. So birds of prey, hence their name, for example, can play an important role in regulating the population sizes of mice, voles, and other mammals. Okay, so we see right here these predator-prey dynamics. Typically what we will see is that the population size of a prey is going to be significantly larger than the predator. Okay, so when we have one increase, we have one decrease as well. And then we reach this tipping point right here. Both will crash, then they will recover. And it's this cyclical back and forth predator-prey relationship over time. Now, if one of these were to go to zero, though, if the predator were to go to zero, the prey population would increase until eventually they run out of those resources that we talked about with the niche. And when that happens, their species would actually die out as well. So an interaction in which one animal feeds on producers like plants is called herbivory. So very dense populations of white-tailed deer are eliminating their favorite food plants from many places across. So as I was saying, we see that very dense populations can essentially eliminate their primary food source pretty quickly if they are not taken care of. Now, we have this example here of white-tailed deer. Now, in the South, if there were no hunting on these white-tailed deer, they would exhaust their population of food source very, very, very quickly. Now, one of the ways that we try to manage this is by seasonal hunting that we have to help maintain their population and keep it from being too high. So this leads us to what is called a keystone species. Now, keystone species can cause dramatic changes in the structure of a community because they are very dependent upon other ones. So we talked about this in a previous lesson when we were talking about food webs and food chains, and we saw that krill can be a keystone species. If you remove that species, it becomes very, very, very detrimental to the entire food web and can cause several other organisms to become extinct. If you read in your text, you'll read the example about sea otters and sea urchins, and that if the urchins are not going to have enough kelp, then they will subsequently die, and then the sea otters won't have a food source. So a century ago, these sea otters were nearly eliminated by hunting, and because this, the kelp forest nearly vanished because there was nothing eating the sea urchins. So otters in this case were a keystone species that helped balance everything out. So recently, however, through a lot of restorative processes, we've actually seen the sea otter population rise again, and hopefully will return to its original level. Now, symbioses. So we have three different types of symbioses that help, or they aren't really help, but show how organisms depend on each other. So any relationship in which two species live closely together is called a symbiosis, which literally is translated to living together. The three main classes we have are going to be mutualism, parasitism, and commensalism. Now, with mutualism, I'll just cut it short for you and say that both benefit. Now, if you remember the movie Finding Nemo, Nemo was a clownfish, and clownfish have the ability to live within an anemone. Okay, or as I said in the movie, I'm an anemone. Now, an anemone will sting other fish, but it does not sting clownfish. Now, if mutualism is both benefit, how does the anemone benefit from the clownfish? Well, the clownfish actually eat little organisms that land and start to grow on the anemone, keeping it clean. Okay, so this kind of relationship where both benefit is known as mutualism. Now, in parasitism is where one benefits and the other is harmed. Okay, so tapeworms, for example, can be found in the intestines of mammals. Okay, things like fleas, ticks, lice, leeches, they live on the bodies of mammals as well. I'm sure that if you have a dog or a cat at home, you may have seen a tick that attaches before, and they will drink the blood of their host organism, and they do that to survive. Okay, so the parasite will obtain all or part of its nutritional needs from the host organism, but generally they will weaken, but they don't kill their host, because if they kill their host, they've ultimately lost their food source. Okay, and typically the host will be much larger than the parasite itself. Now, lastly, we have commensalism. So with commensalism, it's a relationship in which one organism benefits and the other is neither harmed or helped, or we say unaffected. So barnacles that are shown on a whale's skin, so they perform absolutely no service to the whale, but they don't really harm it, and they benefit because as the whale is swimming, they constantly have water moving into their buccal cavity, and it's at that point that they can filter out dissolved food particles that are in the water, and they are able to feed. So if you have any questions about the lesson, post them in the comments below, or put them in the class Hangout on Google, or you can email me at mr.tucker.schs@gmail.com.